Hello, in this video I'm going to say a little bit about globular clusters. They're slightly mysterious objects that are found in the Milky Way and other galaxies. This photo here is of Messier 22. This is the great globular cluster in Sagittarius. And you can pick this one out because you have this red star just located up and to the left, although of course it can be shown at different angles. This different orientations, but that red star is a giveaway when you're looking at M22. And as I say, globular clusters, they're slightly mysterious. I mean, first of all, the things that we do know about them, they are spheres of stars held together by gravity, concentrated at the center. So we've got hundreds of thousands of stars here at high density, relatively speaking. If you think of the sort of density we're used to locally for stars, you know, it's 4¼ light years to get from the sun to the nearest star, Proxima Centauri. In a globular cluster, you're looking at an average separation of about 1 light year. That's our average separation. In the core of a globular cluster, you might be looking at 1/3 or even less of a light year in the core. So that is densely packed. So you get a lot of interaction between the stars. You get collisions, you get mass and matter being passed from one star to another. So you can get some unusual stars inside globular clusters. You can get very high rotation pulsars, like millisecond pulsars. You can get low mass X-ray binaries, where you've got these low mass stars coming into close proximity to each other. There's a lot of energy there that they're releasing as X-rays that you wouldn't get in other situations, not regularly. So yeah, you can certainly get some unusual stars in there. We do know that by and large the stars that are in globular clusters, these are old stars, and they're all old, but they're not all the same age. You know, in a particular globular cluster, you do a spectral analysis of these stars, they're low metal stars, they're old, but they are different ages. So that suggests that there's been multiple phases of star formation. And that's not uncommon in objects. You know, you think of what happens in nebulae. Okay, they're going to contract, they're going to get star formation as they're contracting, and they leave a lot of gas around. Okay, they form a whole load of stars, but you've still got a lot of gas there. So if some other event triggers another phase of contraction of this gas, some kind of density wave passes through or something like that, some other interaction with another object that's going to cause gravitational perturbations, then you can get another phase of star formation. This is what we see in the arms of spiral galaxies, where you get these multiple phases of star formation triggered. And that's what we see in globular clusters. But these are all old stars. Yeah, they have a similarity in terms of their age and their the fact that they're low metal and their distribution. It's got a similarity to, say, a dwarf elliptical galaxy, or the core, the central bulge of a spiral galaxy. It's got that age and distribution, sort of, you know, similar look to them. Right, another thing that we know about globular clusters is their distribution around the Milky Way. So not the distribution of the stars inside the globular cluster, but the distribution of globular clusters around the galaxy. So Messier was the first person who was really observing these. When he was doing his survey of the sky, he was looking for these fuzzy blobs that he thought could get mistaken for comets. So they looked a bit like a comet, but they weren't moving like comets. So he catalogued those in his Messier catalogue. And then William Herschel, the guy with the biggest telescope in the world at the time, he started looking at a lot of these, and he picked out 40 or so which were obviously different. He could see that they were a different type of object that he coined as being globular clusters. We've now got to the stage of about 160 or thereabouts in the Milky Way, and people started plotting out where they are. You know, what's the distribution of these globular clusters in the galaxy? And they noticed that a lot of them are not in the galactic plane. So if you've got the Milky Way, there's the plane of the galaxy. So we're looking at it side on. You've got a central bulge. But we know there's a large distribution of matter in a sphere going around the Milky Way. It's not all in the galactic plane. The galactic plane's the visible bit, or most of the visible bit. but there's a lot of stuff going on in this sphere. And it was noticed that the globular clusters are distributed around this sphere. So that gave a new way of determining where the center of the galaxy was. Because if you get the distribution of all the clusters and say, well, what's the center of the sphere then? That's giving you the center of the galaxy. And we could see globular clusters that were much further away. So that helped with getting this distribution, because if you're not looking in the galactic plane, you don't have a whole load of stuff in the way. So if we're looking at something over here, a globular cluster, well, we can see a lot further because we're not having to try and look past all of this dust and other stars and nebulae and gas, interstellar gas and all the rest of it. It's not blocking our view as we get when we're looking through the plane of the galaxy. So you can get quite a nice distribution of where all these globular clusters are. And people pieced this together in the 1920s, and they've got a new estimation for where the center of the galaxy was. And this caused people to change their map of the galaxy and move the sun much further away from the center. So that was a big breakthrough that happened in the 1920s, getting this new map of the galaxy. So we know how they're distributed. We know, basically what they're made of, but we don't really know how they form. There's a few clues that we've got maybe to their formation. So some of these globular clusters are orbiting the galactic center in a retrograde motion, so in an opposite direction to the orbit of the galactic disk. So we've got the disk orbiting one way, we've got some of the globular clusters orbiting the other way. So this retrograde motion plus the similarity that they have to the centers of galaxies, particularly dwarf galaxies, so small elliptical galaxies or the center of spiral galaxies, maybe that's what globular clusters are. We know they're old stars. We know these clusters have been around for a long time. So maybe they are what's left over of dwarf galaxies, and they've been captured by the Milky Way. The Milky Way is fairly big. So maybe that's what's happened. You had satellite galaxies, things like we've got the Large and Small Magellanic Clouds at the moment. So maybe dwarf galaxies like that have been stripped away, and that's what we've been left with, just the center of them, which are then orbiting around. That is a possibility. That would then allow galaxies such as the Milky Way to capture other globular clusters from other galaxies. It's thought that the Milky Way merged with the Kraken galaxy, a theoretical galaxy that is thought may have existed billions of years ago and then merged with the Milky Way. Maybe the Milky Way then inherited some globular clusters from there. But there are a lot of unanswered questions when it comes to the formation of globular clusters. But they are fascinating objects, and they are great to look at if you've got a quality telescope. You're going to want a decent telescope for this. You certainly won't look at anything that is even vaguely like this in a backyard telescope. These are objects that you can make out, but they do just look nebulous. You won't be resolving individual stars like in this picture. But if you go to a university or somewhere and study astronomy and they've got a decent telescope, then you can see things that look as good as this. I mean, they're wonderful objects to look at through high quality telescopes or large aperture telescopes. So there you go. That's globular clusters for you.